Welcome to my new video. Assalamu alaikum dear friends. My today's video is about gapply, a new addition to the apply family of R programming. Note, this is version 1 of gapply. Version 2 will come soon with the addition of more features, more power and more optional features, and also I will try to remove the bug if any. G here in gapply function stands for geometric. Gapply means apply a function to a series of geometric shapes in a given matrix. For example, rectangles, squares, diamonds, diagonals, rows and columns, triangles, pentagons, and hexagons. I have created the following functions for this purpose. The first function I have created is the mtrx indices. This requires a single argument, that is values. It finds the indices of all the points between given coordinates of a matrix. The second function is the endpoints. This also requires a single argument, that is values. It calculates the number of points falling on that line. GetValues function requires two arguments. One is the name of the matrix, the second is the list of indices. This will get all the numbers or values falling on that line or lines. The fourth function is the apply function. This requires three arguments: the name of the matrix, the list of the indices of the matrix, and the third is the function. It will apply a given function, that is sum, square root, cos, mean, or any other function to the numbers or values falling on those lines. The above functions have already been discussed in detail in my previous videos. If you are interested in these functions, then you can go back and watch my other videos. This is the video about gapply function, which requires many arguments, but three of them are the most important. The first is the name of the matrix, that is the name of the container. The second is the shape, and the third is the function name. So it will apply a function to a series of all the given geometric shapes in a given matrix. Today we will be talking about gapply function. So watch my previous videos for the other four functions. So let's begin. Bismillahirrahmanirrahim. Suppose you have been given a matrix composed of 11 columns and 11 rows, and you have selected 4 points of the corners. That is, point number 1 is at 11, 11, point number 2 is at row number 1 and column number 11, point number 3, point number 4 is at row number 11 and column number 1, and then you want to connect all those points, and then you are interested in counting the number of points that falls on all these 4 lines. For example, you can count these points, that is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. So there are a total of 40 points that falls on all these 4 lines of a square. If you want to calculate the number of points that falls between these 4 given starting points, then you can use my endpoints functions, but here you will require the indices of all the corner 4 points. This will calculate the number of points for you. And if you are interested in the indices of all these 40 points, then you can use my another function, mtrx indices. This requires the same argument, that is the list of the 4 corner points. This will give you the output of all the indices. And if you are interested in the values that fall on these 4 lines of the matrix of the square, then you can use this function, which is called getValues. This function now requires 2 arguments. The first is the name of the matrix. The second is the same argument, that is the values of all these 4 corner points. The output of this function will be the values extracted from these 4 lines. Now you can apply a function to these extracted elements. You can use my apply function for this purpose. This requires 3 arguments. First is the matrix, the second is the list of the indices of all these starting 4 points, and the third argument is the name of the function. This will give you the summation of these extracted elements, which is equal to 411. The code of gapply function will be shown at the end of this video. Note, you need to have the codes of all the functions for gapply to work properly. That is the codes for HCF function, for mtrx indices, for getValues function, for apply function, and for gapply function. You might be aware of the built-in apply function, which you can use to apply a function on the elements of every row of a matrix or on the elements of every column of a matrix. For example, you want to add the elements in every row of a matrix like this. Then you can use this built-in function apply, and it requires 3 arguments: the name of the matrix, the dimension number, that is 1, and the function name, sum. 1 represents rows, 2 represents column. The same built-in apply function can be used for column-wise summation of the elements of the matrix, but the only difference is that instead of 1, here you use 2. So this will give you the output of this. You may be interested in applying a function to all the elements of a matrix. For example, you are interested in adding all the elements of a matrix together. Then you can just simply type sum and then inside parentheses type the name of the container of the matrix. But there may be a situation in which you may be interested in adding or applying a function to the elements of a matrix that falls in diagonals. For example, you may be interested in the summation of the elements falling in diagonals. As far as I know, there is no such built-in function that you can use for calculating the summation of elements falling in diagonals of a matrix. For this purpose, you can use my function gapply. Here you will only require 3 arguments. The 4th is optional here. This DL stands for diagonal left. Why diagonal left? Because these arrows of the diagonals are pointing towards the left side of the matrix. That's why DL. This is the name of the matrix, this is function name, and this vector is equal to true means that you want the output in the form of a vector. If you make it false, your output will be in the form of a list, not in the form of a vector. Instead of DL, you can also use 7 for the sake of simplicity. Output will remain the same. You may be interested in these diagonals. So these are the summation of elements falling in these diagonals. Again, you can use the same gapply function, but this time instead of DL, you will use DR, which stands for diagonal right, because these arrows are now pointing towards the right side. Instead of DR, you can use 9 as well. The result will be the same. Why 9? If you look at these 3 numbers, these are 7, 8, and 9. 8 is in the center of these 3 numbers. 7 is on the left side and 9 is on the right side. That's why I have used 7 for DL and 9 for DR. And 8 have been used for diamond shapes. Okay, you may be interested in finding a solution of these elements falling on these 4 lines. For example, the summation of these elements of the matrix that falls on these 4 lines of a square. The summation of all these points is 411, and then the summation of points falling on these lines of the inner square is 319. The summation of these numbers is 152, and then 4, 32, and of course 4. If you are interested in such situation, then you can use the gapply function for this purpose. Here you will need this string, that is SQ. SQ stands for square. Instead of SQ, you can also use 4. 4 here stands for the 4 corners of squares. This will give you the same output. Okay, now you may be interested in applying a function to the elements falling on these 4 lines of a diamond shaped structure in a matrix. For example, the summation of these elements is 146. The summation of elements falling on the lines of this diamond is 84. These elements summation is 51. The summation of these elements is 31, and then 16 and 4, of course. In the gapply function, you will need di as a string. Di means diamond. Instead of di, you can also use 8. Just to remind you that I showed you these three numbers in my previous slide, where I told you that 8 is in the center, 7 is on the left side for diagonal left, 9 is on the right side, which is used for diagonal right, and 8 is in the center. That means here we have arrows pointing towards the left side as well as arrows pointing towards the right side. So it is in the center of these two numbers. You may be interested in elements falling on the three sides of a triangle in a matrix. So the summation of these elements is 179. The summation of elements falling on this inner triangle's sides is 98. And the summation of these numbers is 62. Summation of these numbers is 35. This is 18 and this is 4. You just need this string in gapply function, that is tr. Tr stands for triangle. This time you need an additional argument which is called direction. Here direction is equal to 1 because the tip of all of your triangles is pointing upwards. That's why you have used direction 1. If the tips of all these triangles were pointing towards this side, then you will have used direction is equal to 2. And if it is downward, then direction 3 and so on. You can use 3 instead of tr. 3 here stands for 3 sides of the triangle. It will have no effect on the output. Output will remain the same, whether you use tr string or number 3. Now let's come towards understanding the directions of the triangle. If the tips of all of your triangles are pointing upward, then you will use direction is equal to 1. If all of the triangles are pointing towards the right side, then you use direction is equal to 2. And if all of the triangles are pointing downwards, then you use direction 3. And for these triangles, use direction 4. There may be some other situations in which your triangles may be pointing towards the 4 corners. In this situation, the tip of this triangle is pointing toward the corner. Here you use direction 1, 2. If it is pointing towards this corner, then you use direction 2, 3. And if it is pointing towards this corner, then you use direction 3, 4. And if it is pointing towards this corner, then you use direction 4, 1. Why 4, 1? Because this is the direction 1 and this is direction 4, and this tip is in between these two sides. That's why the direction of this tip is 4, 1. So this is the function, and this is where you need your direction. Now let's apply the gapply function to the row-wise summation of elements of a matrix. The built-in function for this purpose is apply function, but you can also use my function gapply. Here you will need this RW, which stands for row-wise summation of the elements of the matrix. The output will be just the same as the output of this one. You can also replace this RW with 1, just like you use 1 in your built-in apply function. You can also use my gapply function for column-wise application of a function. For example, the summation of these elements that falls in these columns of the matrix. The first is the basic or the built-in apply function, where you use 2 instead of 1. 2 here means column-wise summation, while 1 stands for row-wise summations. You can use my gapply function. In gapply function, you will have to type this CW string, which stands for column-wise. You can replace this CW with the same 2 as you used in built-in apply function. If you want to use my gapply function on all the elements of the matrix, then you will have to type all here, or you can also use 0 instead of all. So if you type string all here, it would mean that you are applying this function to all the elements of the matrix. While the basic function or the built-in function for the summation of all the elements of the matrix is sum. Now let's come towards the parameters of the functions. This function has got many parameters. mtrx. This is the name of the matrix, the name of the container, for example M. The second parameter is shape, that is the values and jumps. Geometric shape to which the function is applied. For example, SQ stands for square. Instead of SQ, you can also use 4. TR, for example, stands for triangle, and instead of TR, you can also type 3. One thing must be remembered here is that direction is must with TR. Direction can be used in combination with TR. The next argument you can use is DI, which stands for diamond. Instead of DI, you can also type number 8. The next argument you can use in the shape parameter is DL, which stands for diagonal left. Instead of DL, you can also just type number 7. Remember, switching must be true in case of DL as well as in case of DR. DR stands for diagonal right. You can also type number 9 instead of DR. RW stands for row wise. Just like apply function, you can also use number 1 for row wise. CW column wise. Just like apply function, you can also use number 2 for column wise. All means all the elements of matrix. You can also use 0 in place of all. The next parameter of the function is func. That is a function you want to apply to the shape. For example, sum, product, cost, log, square root, mean, median, variance, standard deviation, etc. Another parameter of the function is vector, which can only get two values, that is either true or false. If it is true, the output will be in the form of a vector. If it is false, the output will be in the form of a list. This argument, that is direction, it can get values like 1, 2, 3, 4, 1, 2, 2, 3, 3, 4, or 1, 4. This parameter only affects the output if shape is TR. Switching. This is compulsory for DL and DR. It should be true for DL and DR. Otherwise, it will print out half of the result twice. How many? If your normal output is 4, 2, 3, 8, and 9, and you need only 2 of these 5 numbers, then how many should be 2? The next parameter is steps. It affects the normal output. The above output had 5 numbers because steps were 5. That is loops. It is different from how many. How many cuts the numbers from normal output, while steps cuts out the number of loops. Actual. If it is true, you only get the non-repeated full output. If false, the output may contain duplicated or values that do not match the shape. Half. The normal output is usually a duplicate. That's why we only need half. So it should be true. If false, you may get duplicated output. However, it's not always the case. Values. A list of starting points, indices of a matrix. If shape is equal to values, you will need this argument. Jumps. How many rows and columns each starting point should move in each step. If shape is equal to values, you will need this argument as well. So these two arguments are required argument in case shape is equal to value. Cycles. How many repetition of the steps or jumps you needed. In to out. If true, the function will be applied to the innermost square first. Otherwise, the outermost square is first. Only affects the squares in version 1 of the gapply. Okay, now let's apply mean function to the diagonal left elements of a matrix. For this purpose, you will have to type gapply, matrix will be equal to M, shape will be equal to DL, function will be mean, and vector may be true or false. You can also type this function replacing the DL with 7, or you can just omit all the parameters of the gapply function. You can just type the arguments of all these 4 parameters in a correct sequence. Here M is the name of the matrix, DL or 7 stands for diagonal left lines, mean is the function we are going to apply each diagonal left line separately. True, that is the output will be in the form of a vector. Now let me show you the codes for gapply function and also the apply function, because gapply function depends on apply function. An apply function depends in turn on getWells function. GetWells depends on MTRX indices, and MTRX indices depends on HCF. So let me show you the codes of all these 5 functions. So this is the code for the HCF function. You can pause the video and then copy this code in your script area of your RStudio. This is the code for the second function, that is MTRX indices. And this is the code for the getWells function. This is the code for apply function. And here is the code for version 1 of gapply function. The code of this function is very long. You can pause the video at different times and copy the code. So this was the code for gapply function. This is me sitting on a rock in my village. And now the dedication. This code is dedicated to my roommates at the apartment in State College, USA during my visit to the Penn State University in 2008. So thank you for watching my video. I will show you the advanced usage of gapply function in my next video. Note, this was version 1 of gapply. Version 2 will be shown in some other video. Keep watching and take care. Bye.